Actually, I might move this just a bit closer because it's still pretty far out. At times like this, it's a good idea to disable the snap grid just to get it to the closest possible area you can. Cool, re-enable. The other thing that I think would be a good idea is that's a white character right now, but instead it might be a good idea to make it just a strong contrast. Now at the moment, if we were to run this, the U is actually not going to stay attached. This is going to drop down and the U is going to stay where it is. And that's because my text render component here isn't set to DT mesh. So this hasn't actually, I had to make sure that DT mesh was the parent of the actor that I was dropping in. Now finally, the other thing that I'm going to do here is I'm going to create a variable that is just going to be, it's going to be a string variable to keep things simple. And it's going to be called drop letter. So I'm going to expose this, and I'm also going to expose this on spawn, and I'm going to set the type to just be a string, compile, save, and all this is going to be by default is a letter, so I'm going to put in F for the sake of testing, and in my construction script, I'm just going to get my drop letter, so when the construction script runs, it's going to get my text render component, and it's simply going to call on the text render set text. And the value that it's going to be looking for is just going to be drop letter. It's going to add an auto conversion because we're going from string type to text type, but that's okay, we can leave that. So now that we have that going, compile, save. If I hit my viewport, you can now see that whenever I change this variable to be something else, it's always going to equal that again, which is great. So now that we've got our drop target essentially created, the next thing that we need to do is create actor components in our new blueprint. So the variable band is in place, the drop target has been created. It's time for us to go about actually creating the final piece, which is to create an actor that we're going to call a drop target set. So I want you to right click on BP variable band and instead go create child blueprint class. Now I'm going to call this BP underscore drop target set. Okay? And you'll notice that when it's created, it looks identical to a standard variable band, but there's more to it. So how this is going to work is I'm essentially going to add actors to this actor according to the word that is specified as its variable, which means we need to go ahead and create ourselves a new variable that I'm just going to call drop target string. And I'm going to set this be a string variable. Compile, save. We're also going to make sure that this is public. And in my construction script, I'm now going to go ahead and create that functionality. Now I want to point out something. At the moment you can see that we have construction script and we also have parent construction script. This means that as long as this node is here, this node executes what its parent would normally run in its own construction script. Whereas everything beyond this point is going to allow me to expand upon that so that this actor has all of its functionality of its parent plus a little bit more. So in this case, what I'm going to do is, first off, I'm going to get my drop target string, and I'm actually going to run a quick little function on it called toUpper, because anything that we have that we're putting in here, I want to make sure we're only using capital letters. So I'm going to now set the drop target string to be the capitalized version of the existing string. And now I'm going to drag off of that, and I'm going to type in a function called getCharacterArray from string. This is very useful because what it does is it breaks any string, so line of text given into it here, into an array. Now I'm going to put in a test array at this point that'll just be a simple word. And what it's going to do is eventually this is now going to put out Udemy, and under getCharacterArray from string, this array is now going to have one letter in each single value of its array. So I'm going to drag off of that and I'm going to do a for each loop. Now this for each loop is going to create a child actor component every time it iterates through. So what we're going to do is I'm going to drag off of the loop body, and for the time being I'm just going to add a child actor component. Now a child actor component means we're spawning a new actor that's parented to this as if it was a component of this actor. It's very useful functionality. I'm going to do drop target, and for the time being I'm going to tell it that it's relative transform. So we're just going to make this up as we go along as a quick test, but I'm going to go split, and I'm going to just, for the time being, tell it just so you can see that they're all being added, that it's Z location, so this is going to go straight up, which is obviously not what we want in the long run. But I'm going to multiply the index, which is the current number in the array, multiplied by, let's say, 40 for testing. I'm going to plug that into here. This is set to drop target, and this is set to there. So if I go view compile, you can now see that it's added letters going up again and again and again. So we know that it's adding these actors to our world. So this means that what we need to do is essentially we need to create something in our construction script that tells it where to place those actors. And if you think about the logic that we need to have there, let's have a look at it. We start here and we end here. We want to find the spaces in between and automatically place them. Now, we don't want to use the very ends. We want them to only be on the band. So a nice way for us to go about doing that is to, first off, we want to get the length of the distance between the two posts of our parent. So if I was to right click here and just, try to add a reference to post, I could, except how would I ever get my second post? So it's time for us to quickly expand something that we had in the variable band, and that is I'm going to go to here, and when we add the static mesh component for the second post, which is this one just here, I want you to right click and promote that to a variable that I'm just going to call post2. This means that at any stage, if we want to modify post2 in the future, now we can. So I'm going to compile and save, and then go back to my drop target set. And this time when I right click here and I type in post, you can now see that we have get post2, which means I can get a reference to both of these. So post 1, we want to get the relative location. Post 2, we want to get the relative location. At which point we want to subtract one from the other and then get the length, which tells us how far apart these are from each other. So this is a nice little function to quickly tell us how far apart these two things are. Now, all I want to do from here is I want to figure out how spaced out the intervals should be given how far apart these are. So I'm going to use this, and I'm going to divide it by the number of characters that we want to have. So to do that, I'm going to get this, the length of this, and I'm actually going to add 1 to it so that it never fills up and adds an extra element to the end piece. So we've got the length plus 1, and what I'm going to do is, so I'm just going to clean this up as we go, reroute, and what I'm going to do is I'm going to divide by a float. I'm going to divide this by this. So the length divided by the number of pieces we want to have plus 1 so that we have a little bit of extra space on the end. At which point, we now want to multiply that, because if I was to get this and just plug that, for instance, into X, well, the first issue that we have is we haven't gone ahead and told it where the gaps are. This tells us how far apart to place them, but we need this, there we go, to tell them where that specific element should be. Now, this is not going to work when I plug it in, but you'll start to see what's going on. Compile. You can now see that these are getting arranged in a straight line. And if I was to go and modify the value that we have for the location, so I'm going to delete this for the time being and instead put in a drop target set. If I was to add this and click on post location and stretch it out, you can see that it's expanding that space. However, it's still not correct. Now, the reason it's not correct right now is we're offsetting by 1 on one end, but we need to offset it by 1 on the other end as well. So I'm going to go to my drop target set, and in my construction script, I'm going to add 1 to my array index. These pieces are now being correctly placed here. However, we have another issue. If I was to get my drop post and move it, it's sizing them along the x-axis, but it's not actually sizing them in a way that is between the 2 points. It's just going along its own local x. So how do we fix that? So we go to the drop target set, and what we do this time is after we've multiplied that by that, we now want to actually offset it so that it's facing down the direction of the post. So there's a great way to do that, which is if I get my post 1 and I find out which way forward is for that actor, I can now multiply this number. So keep in mind, at the moment, this is just a distance, saying here's how far along you should be. And by multiplying that against a direction, oops, that should be a multiplication against a vector. So multiplied vector by float. By multiplying these two against one another, I'm going to recombine this for a moment and plug this in. You're now going to see that if I get this, it's starting to actually place them in the correct location. So see, they're now actually stretching between the two locations. However, we have one final issue here, which is we need to make sure that the rotation is correctly set up as well. And that's okay, because the rotation just needs to be the rotation of this against, sorry, where is my drop target set construction script? It is the local rotation of the post one. So I'm going to get relative rotation and connect this. And you'll see that these pieces are now correctly aligning themselves with the post, because we're already doing the rotation math. Now that that's out of the way, the only thing that we need to do from this point on is to actually add an offset so that these aren't just sitting in the middle. Now, if this is the forward vector along that direction, this would be considered the right vector. So all we need to actually do here is multiply the right vector by, say, 20 units and add that to our location. And what you'll see there is this. So we're getting the right vector at the moment and making that our location. Sorry, the forward vector, making that our location. But if we plus vector, so we're adding an offset, and this offset was simply equal to the post, we get the right vector. So that the right vector is a vector that points in the direction of the right of the object. By multiplying that against, say, 20, it's now going to be 20 units to the right. What does that mean? It means that it's now going to place those here. Save. Now at the moment, these are all being set to U, but they are being correctly placed now. So the final part for us to do in setting this up is to go back to our construction script, and after we add them, we now get this. Now, most people would expect this to return an actor reference, but it actually gives me a component reference, because remember, these are actually components in here. So what I need to do is drag off of that and type in child actor, and you'll see that we now have the ability to get access to the child actor. So with that, all I need to do is drag off of this, cast to drop target. So we're going to cast the actor to a drop target. And because it's a drop target, I'm now going to set the drop letter. And the drop letter is going to be equal to the current letter. So I'm going to get this and plug it straight in. Now there is still going to be an issue here, which is, well, you'll see in just a moment. If I go compile save, you can see that those are all still U's. Now the reason for that is that the function that we added in our drop target, which was to automatically set the letter in the construction script, this functionality doesn't actually work if we're doing it through a child actor. So we need to set that up a bit differently. So to do that, we go to the drop target set, construction script, and after we've set the letter to the correct letter, let's also just simply call set text on the text render that we've added. And I'm just going to make that equal to the letter that we set it to just then. So we're essentially replicating a construction script functionality here. If I look at this in the world, you can now see that this will automatically expand and contract where it can, and add the word that we've created, which is fantastic. So let's see how that actually works in a game. I'm going to add this word here, and I'm going to move the piece over to here, just so we have something that is theoretically easy to hit. And you can see that every time I hit them, they're now dropping. So going from here, the next thing that we need to do is to make sure that this actually knows how to handle itself from this point onwards. So it needs to know that when it drops, that we're actually assessing the number of things that have dropped and checking whether it's time to add a multiplier from this node yet, which means it's time for us to start looking into some extended behaviors, which are going to be event dispatches. So we'll do that in the next lesson, but for the time being, write something cool, place it somewhere that's difficult to kind of reach but still reachable, and expand your general play area. So this time around, what we're going to be doing is using event dispatches as a way of communicating between blueprints. In this case, we're going to use the drop targets that are aligned along the drop target set to communicate back to the set whenever they've dropped. When they have all dropped, we're now going to pass that information onto the game mode and increase the current game's multiplier. So to do this, what I'm going to do is I'm going to go into my drop target and I'm going to add an event dispatcher. So this is going to be a rather simple one. All I'm going to do is I'm going to add an event dispatcher and I'm going to call this onDrop. Now essentially what we're going to be doing is, this doesn't need any inputs set up here, so for the time being this is fine. What we're going to be doing though is we're going to say onDrop, anything that has been bound to this event is then going to call a respective function accordingly. So within my drop target, I'm going to drag this over and I'm going to say call. So now, on hit, we call drop, and when we drop, we're going to call onDrop. Compile. And now in my drop target set, what I'm going to do is, in my construction script, I'm going to go ahead and add a binding such that when the game actually creates all of the drop targets, so when the construction script is run, what I'm going to do is bind an additional event to this. So to do this, what we need to do is follow along here. We can see that this is the point where we add the drop itself. So afterwards, I'm then going to say, after we set the text, let's do one other thing, which is going to be, as BP drop target, I'm going to bind on drop. So I'm going to bind an event to onDrop. I'm just going to plug this in here. Now, because we're in the construction script, I actually want to bind this to a function in the event graph, well, an event in the event graph. So I'm going to right click in the event graph and I'm going to create a custom event that is just going to be called process drop targets. So every time a target drops, it's going to run this function. And to do that, what I need to do is go back to my construction script, and in the event, if I drag off of this, you can see that we have a couple of options, but the one that I want here is create event. So I've dragged off of the red pin, at which point I'm going to select process drop targets as the function. This means that when onDrop gets called on this child actor component that we've created, it's then going to call process drop targets on this actor. So whenever we call process drop targets, let's think about what we need to do. Well, we need to step through, we need to keep track of how many drop targets we currently have. We then need to decrement it, so we need to remove one because one has now gone down. And if the current number of targets remaining is equal to 0, we then do something to the game mode. So for us to do that, we're going to need an additional variable, which is just going to be called target counter. So this is the number of targets currently in there. So I'm going to go integer. Now, this is going to be set up such that when process drop targets gets called, we're going to get the current target counter. So I'm going to get, and I'm going to type in minus minus, which means decrement. So subtract 1 from it. Now after I've done that, I'm going to see if this is equal to 0. Because if this is equal to 0, we're going to do a branch, because that means that all of these have dropped down. So we're going to do a branch, at which point we're then going to modify the multiplier back in our game mode. So in our game mode, we currently have a value called multiplier, and all I'm going to do is I'm going to get the game mode, I'm going to cast it to the pinball game mode, I'm going to get the multiplier, and I'm simply going to drag off of that and type ++. So increment float. And then I'm going to connect this up and connect this up. Now, this is currently missing something. At the moment, we're never telling the target counter what it should actually be equal to. So there's a couple of different ways that we could do this, but what I think I should actually do is add one more quick custom event, which is going to be in the game mode, which when we reset, we want to, whenever the game gets reset, we want to make sure that we've bound the values to be the current counter again. So every time the game gets reset, we want to actually set target counter to be back to that. So to do that, what I'm going to do is in my game mode, under reset game, I'm going to add an extra call just at the very end here, which is simply going to call an event dispatcher. So I'm going to create another one, which is called onGameReset. And I'm going to call this here. And in my drop target set, I'm simply going to say on begin play, we want to get the game mode. So I'm just going to copy and paste the game mode reference here. So on begin play, let's get the game mode. And let's very quickly just bind to onGameReset, which is what we called it. So we're binding to this here. And the event that we're going to be binding is simply going to be called, it's going to be called reset drop target counter would be fine. So I'm going to create a new custom event. Oops. And it's going to be called reset drop target counter. And this, now I could actually just plug this straight into here if I didn't want to do the custom event, but this can get kind of messy doing it this way. It's okay for the time being though. And all I'm going to do is say target counter is equal to the length. So get the, I've grabbed my target string, the length of the string. So compile. Now we're getting a little error here. Oh, now the reason it's just throwing an error is because I compiled this before compiling the game mode. So if I go back to here and hit compile again, it'll be totally fine. The reason being is that it's the game mode that had the delegate in it, the event dispatcher. So we've created that. That's now able to reset there. Now I believe reset game is currently being called whenever we create the game itself. So we should be fine. On begin play, we call create main menu, which on play resets the game. Yep, so this should be fine. So there's one last thing that I want to do here, which is in my drop targets. I'm going to, again, I'm going to set these up such that on begin play, I'm going to bind reset. So the reset function that we've already created, reset target, is going to be set so that when the game resets, we're going to be doing that. So once again, I'm going to drop in my pinball game mode. I just pasted it in from earlier. And I'm just going to bind on game reset. We want to go event dispatcher, create event. And I'm going to say reset target, which is the function that we created earlier. I'm going to compile and save. So now when the game resets, all of my targets should also come back up to the top. So with that done, we should be ready to test this out. So if I were to hit play, okay, so we've had one tile fall down. Now let's quickly test if these reset. 1, 2, 3, and this should be my last life. So now when I hit play again, you can see that that pops straight back up. Fantastic. So we've gone through and we've gotten most of the assets together. One last thing that I'd really like to add here is a slingshot, which is just a reasonably standard pinball asset. You'll recognize it once we start to get it in. And to do that, I'm going to need to just copy in the asset, same as before. So I'm just going to go to my assets folder and I'm going to pull up the asset to copy in, which is going to be called SM Slingband MT. So I'm just going to drag that in. And when it imports, I'm going to leave all of this the same. I'm going to auto-generate collision as well. And just click import. Now this asset has something different about it to the others. And what that is that if I was to open this up and quickly show you the materials. There are 3 materials for the surface and for the base sections, and then for this band running around the middle. Now this band around the middle has actually had morph targets applied to it, which is just a simple addition that we can add in 3ds Max that allows us to have kind of like a very, very basic pose saved into it, so a single animation as to where it would end up. And the reason for this is we, through the material, can modify these morph targets to actually expand the band out and pull it back in again to create that slingshot effect. So to do that, it's rather simple. What I'm going to do is I'm going to right click and I'm going to create a new material, and this material is going to be used as the morph band. So I'm just going to create that now. I'm going to right click, new material, m_morph band, and this morph band is going to be set up reasonably simply. All I'm going to do here is I'm going to set up first off the color, so I'm going to hit V and drop in a vector parameter which lets me set a color that can be instanced. I'm just going to call this color. I'm going to set the roughness to be very low. 0 is actually probably good for this. And next up, I'm going to right click and I'm going to type in static morph, and you'll see that we have static mesh morph targets. So when static mesh morph targets is loaded, what it actually is doing is it can read in a final position. So if I was to get that position and run it into a world position offset, it actually lets me say where I want each vertice to end up in. So to do that, all I need to do is if I was to just plug this in, it would end up in the final position that's been saved into the mesh. Now we're not going to see anything here because this sphere doesn't have anything saved into it. But I'm going to just plug that in for the time being so you can see it. And I'm going to hit apply and save. I'm also going to quickly just set this color to actually be something reasonable. So let's just go with like a yellow. That'll do. Save. Now all I need to do to test this out is I'm going to go to my sling band MT, and I'm just going to send this bottom material to be my morph band, and you can see now that it's completely stuck out. So yeah, this has just popped out here, and if I was to unplug this and hit apply, it's now pulled back in. So what we need to do is get this parameter that allows the band to shoot out, and basically just set it between a value of 0 and the final pose. So no morph target versus full. So to do that's rather simple. I have just held down L and left clicked to add a linear interpolate. So we call this a lerp. And I'm going to plug in WPO into the B channel. My alpha is going to be a scalar parameter that I add by holding down S and left clicking. So remember, a scalar parameter is a singularly modifiable value. So I drop this in, and I'm just going to call this %out, and initially that's going to be a value of 0, but if I was to push that up to 1, it would be popping out. So with that done, it's essentially all I really need done for this material, because we're going to be modifying it through the blueprint itself. So once again, I'm going to go pinball and I'm going to go blueprints, get a right click and create a new blueprint class, and this is just going to be called BP_slingshot. And my slingshot asset is going to be reasonably straightforward. All I'm going to do is I'm going to set it up to have the static mesh of the sling. So add a static mesh component, set it to slingshot band. I'm now going to get this and I'm going to make it the root. Now we only really want the sling to pop out if it touches this here. So I'm going to add a component, and it's going to be a capsule collision. So this capsule collision is just going to be a little zone in front of it that we're going to use to determine whether we should be popping it out or not. So I'm just going to pull this up. Because my snap grid's too high, it popped all the way up top, so I'm just going to turn that off by clicking on the grid. So this is probably okay initially. We can clean this up later if we need to. So that's just there, and all we're going to do here is in the event graph, I'm going to say on begin overlap, so this collision capsule overlaps all dynamic and it generates overlap events, so it's correct. Now on begin overlap, we're going to check if the other actor is a ball. So I'm going to cast it to a BP ball, because we only really want this to do anything if it is a ball. Now, if it is a ball, what we want to do is add an impulse, which will automatically get me a reference to the ball mesh. And we're going to set that impulse to be equal to, this is a cheeky little way we can do this. If I click on this, you can see that the red arrow is pointing that way, which actually tells me my forward vector. And in this instance, all I actually really need to do is say I want to go this way. So if I tell this to go negative impulse on the forward vector, it'll push out against the red arrow here. So to do that, if I go and get my capsule, get forward vector, which is the red arrow, the x-axis, and I multiply this by a big number to give it some projection. So I'm going to multiply it against a float. That's just going to be set to, say, negative 2,500, sounds good. And I plug this into here. Cool. All I need to do now is do something to actually modify the static mesh's material. But first off, let's just double check that it works. So I'm going to go into the world. I'm just going to add a sling. This sling by default is quite small, so I'm just going to make it equal to, say, 2 times larger. In the process, I might move these around as well. And I'll get rid of you. Okay, so we can put this here. And if I alt drag it, we can now put another one over here. If I right click, I can transform. And I can mirror it as well, so we can get that nice, just 2 assets kind of popping up there. Actually, let's face it this way instead. That's nice. Cool, very simple. So to test this, I'm just going to now hit play. So that seems to have worked. We got a little bit of a bump out of it, but it's going to be a lot clearer as to whether it's working or not if we go ahead and add a quick timeline so that we can see the band kind of shoot out. So to modify the bands, all I'm going to do here is after I add an impulse, I'm going to get the static mesh and I'm going to change the variable in its material. Now, because I'm going to be changing a variable in its material, it's a good idea for me in my construction script to get this and just type create dynamic material instance. And when it asks me which one, I know that it's the channel 2. Remember, it's indexed by 0, so it's element 2. We can see that if we open up the mesh, element 0, 1, 2. So this is the one that we want to make an instance of. So I'm just going to quickly plug that in, and in my event graph, I'm going to get the material. It's going to be material 2. I'm then going to cast to dynamic, at which point I'm simply going to set scalar parameter to a value. Now, what we actually need to do here is we don't just want to set this value one time. Like, we don't just want to set it to the value of 1, for instance. What we actually want to do is set the value to be equal to something that we're projecting from a timeline. So I'm going to disconnect this here. Instead, I'm going to drag off, and I'm going to add a timeline. And this is just going to be called sling bounce. So update is going to be plugged into there. And we're going to double click on sling bounce and add a float parameter. And this is just going to be called bounce. And all we're going to do here is rather simple. We want this to be a way of adding a key at 0, 0, so I'm just going to set the time to 0. So this is where it starts, at which point we're going to right click, add a key. Keep in mind you can also shift click, just for me it's a force of habit for right clicking. So I'm going to add that there, and this is going to be equal to a value of, I want this to push out pretty substantially. I'll set it to 1 for the time being, but my gut says it'll end up as around 2. Now, because this value here is linear, you can see that it's coming off like this. If I click on any of these and then hit 3, it'll automatically add that nice curve to them. So I actually want this to kind of spring out rather quickly and then kind of pop down. So I'm going to move this across. Also, if you're not sure which of these you want to use, you can open this up and set it to any of these. Auto's usually pretty good. So I've plugged this in and we've now got a rather basic timeline. Compile, save. And if I was to go to my event graph and just connect bounce to here, it's now going to just interpolate that value. Now remember, we have to put in the parameter name of the value. And in our instance, the value is called %out. So I'm going to have to change this to say the word %out. At which point, when it gets hit and enters the capsule region, it should now eject. There you go, and you can see that popping out now. Now, one thing that we've gone and done is it will only play one time right now. And the reason it's only going to play one time is we're currently telling it to play. But we actually, every time this goes in, we want to get the elastic band and play it from the start again. So I'm just going to disconnect that and plug it into play on start instead. Compile, save. We should now have a fully functioning band. Pops out multiple times in a row. So we know that's working. The final thing that we really need to do is make sure that when we hit it, and we know that it's the ball, that we add a score. So I'm going to add a quick function that's going to, I'm going to add a quick call that lets us add a score to the game type. So we've already got this, we know. All I need to do is, after we've verified that it's ball, before I add the impulse, let's go ahead and quickly, just going to move this across. I'm going to get the game mode. Cast a pinball game mode. If that somehow fails, which it shouldn't ever do, we'll just go straight through. But if, as long as it doesn't fail, let's go ahead and add score, which is that function that we've already created. Let's say these are worth 20 points. And just plug that in there. So that'll add score now every time. If I hit play. You can see it's adding a score. Fantastic. So the only other little thing that we really want to do here is go back to the mesh itself. And let's just quickly set up the materials to be just a little bit nicer. I'm going to set this to be a yellow band on top, and I'm going to set the middle one to just be simple metal, just so we've got a completed asset in there. Save. There you go. Now from here we're going to be doing some polish passes, so we're going to start adding sound effects to everything, as well as adding some particle effects where necessary. So stick around, jump into the next lesson. So aside from the materials, the other thing that we need to fix right now is the collision. So I'm going to click up here and view it, and you can see that this is currently set up so that it creates this very weird shape. So initially I'm going to click on that and hit delete. The other way you can do it is collision, then you can go to remove collision. There's nothing there at the moment, so it's grayed out. And what I'm going to do here is I'm actually going to tell it that I want it to auto-generate collision based purely on this top piece. The rest of it's going to kind of throw it into confusion. So I'm going to go down to LOD 0, and just temporarily I'm going to turn off collision on the posts as well as on the band itself. So it's just on this top section here. I'm going to do convex collision set to around 20 max Helverts. I'm going to click apply, and then we just wait a second. Now keep in mind that what I generate here is only going to be on this top area, but I kind of actually want this to go the whole way down. So there's a nice little thing that I can do. If I click on it, you can see that it lets me select the collision. So I'm going to get this and drag it down. And now I'm going to hit spacebar, spacebar, and instead I'm now going to start scaling it upwards. Now, because of the offset between where this was and the ground, as I scale it, it's going to push it upwards, but that's okay. It's really only a thing that we need to kind of deal with once. So I'm just going to drag it this way until we get something that's about there, a little bit taller. So now we've gone ahead and just created a very simple collision block that goes from the top down to here, which should be a bit better for gameplay. So I'm going to hit save, and then we're done within the sling band itself. So let's start looking at incorporating sounds into our project. We've already done a rough pass on these bumpers, but it's time for us to actually work on different types of sound. Now, to begin with, I'm going to show you a standard wave implementation. So a sound wave is different to a sound cue, which is the other type of sound format that we typically use. How this works is a sound wave is the raw audio that would be imported when you first brought a wave file in. So we use these when we don't need to care about attenuation, we don't need to care about anything that is related to distance, we just kind of just want to play the sound generally, which makes it ideal for things like UI sounds and music tracks. Now, a good example of how to do this is for me to initially use this victory music loop that I've imported. So I'm going to double click on that, and in the sound wave, I'm just going to say looping. Now, you only ever need to set this version of it to looping if you're only going to be playing the wave and not a cue file. So I'm going to go blueprints, and I'm going to open up my game mode. There we go. Now that we've opened up our game mode, let's go to our event graph and let's look at our begin play. So when the game first begins, we call create main menu. But let's do one other thing. Let's play sound 2D. And this is just going to be called victory, which will load in the wave file that we've now assigned. So from here, I'm going to hit compile, save. So we can see that that works. Now, the next format after we've done a standard sound wave is going to be going into this and actually adding sound cues. Now, we've already added a basic bumper hit, which just sounds like that every time. And if you remember, the bumper hit that we added randomized between different sound effects. In this situation, what we're going to be doing is we're going to be changing one extra setting. So that extra setting that we're going to be changing is the attenuation settings. So if I right click and I create new sounds and I go to sound attenuation, you'll see that this is an option just here. If I click on that, I'm going to make one that's called pinball attenuation. So this is going to be the general attenuation file that we use for every sound. Now how it works is very simple. We set it up so that these settings automatically will get loaded into any of the cues that we're using. So the settings that I really want to change here are things like the radius and the fall-off distance. In this case, what I want to do is say that any sound that plays has a radius of 1,000 units. And if my head was theoretically within 1,000 units of the sound, it would be at full volume. The next thing I'm going to do is the fall-off distance, which controls how far it actually reaches out. And I'm going to increase this to 4,600. So this means that it's going to fade between that distance and the radius to slowly drop off to nothing. Now, I'm also going to make sure that spatialization and attenuation are enabled, which just means that my left and right ears can tell a difference, which is very useful because it means that if the hits a bumper on the right-hand side, I can hear it in my right ear. If it hits something on the left-hand side, I'll hear it in my left ear. So that's our attenuation setting. And first off, I'm going to apply that to the sound that we already have called bumper hit. So I'm going to double-click on that. And I'm going to change the attenuation setting to be pinball attenuation. Click and save. Now that we've done that, let's go ahead and actually make a cue file for when the ball first gets dropped into play. Now there are a couple of options we could use here, but I think ball launch is what we can use for when the plunger lets go and hits something. We've got ball loose, which is a good one for when the ball first comes into play. And then there's ball release, which we could potentially use as well for when the actual thing releases. It's up to us as to which way we want to go about it. But in this case, the one that I definitely want to have set up initially is ball loose. So we're going to play this every time a ball spawns. So I'm going to right click and I'm going to create a cue file. I'm going to keep the default name, which is just ball loose cue, because it's pretty descriptive as it is, and we now know that it's differentiated by being a cue. I'm just going to move this over to here, and I'm going to set the attenuation setting to be the pinball attenuation. So that'll automatically then get all of the attenuation settings that I would typically have. I'm going to hit save. And now under here, I'm going to go to my blueprints. And all I'm going to say is that in my BP ball, whenever the ball first enters play, so a ball is first spawned, I'm just going to play sound. Now there are a couple of options for how we do this. If we want, we could spawn the sound attached, which would be spawned to the actual component itself. We could also play the sound at a location. So there's a couple of different ways that we really want to set this up. In my opinion, it's probably going to be simplest if we just spawn the sound attached, because it's not really going to be moving around. So I'm going to get the spawn sound attached and simply just drag the ball into that. So attached to component is the ball component. I'm now going to set the ball to be the ball loose queue. I'm going to hit compile and save. And now when I hit play, it's a little hard to hear over the music. So I'm going to quickly tweak my music overall volume by going back to my game mode, clicking this button, and just setting the volume multiplier to 0.25. Compile, save. And now when I hit play, there you go. So I can hear the ball automatically is playing that sound every time it gets brought into play. And if this ball were to come out of play, I hear the new ones spawning again. So that's it for those initial basic sounds. From here on in, it's a good idea for you to start going through and adding some sound effects to each of the elements in your environment. So please go through, add some sound effects for the flippers. You'll notice that we have a left flipper and a right flipper. So this actually has a pre-done stereo sound for flipper left and flipper right. So you can plug them in without any issues. So go through, set things up for different sound effects. I'd also consider binding a sound effect for when all of these come down. There's a couple of nice little ones that you could potentially use, such as the bell noise for when this goes down. The bell is this one. Or this one. So you could do the bells for every time these singular letters come down, and then the bell impact for when they all go down, as a signifier that the multiplier is kicked in now. So go through, and when you're done, move on to the next lesson, and I'll show you how to add a audio component to the ball that's constantly rolling and fluctuating in pitch and in volume. So for this part of the tutorial, what we're going to do is get the ball, and we're going to add a constant rolling sound effect to it. And this rolling sound effect is going to just follow it around, and it'll always be attached to the ball. But we're then going to modify this sound so that when the ball stops, it stops. And when it starts again, it starts again. And according to how fast the ball is currently rolling, we'll shift its pitch and we'll shift its volume just a little bit. So how do we do that? Well, we begin by getting this pinball rolling sound, right-clicking, and creating a cue. I'm going to get rid of the 0, 1 on the end of the cue here, because it's unnecessary. At which point, I'm going to open it up, and we've initially got this, which is just a basic rolling sound. However, one thing that I would like to do here is I want to click on this, and you'll see that we have an option called looping that I can just enable. So I'm going to turn that on. Now, it's important to note that when we're using a cue file, you need to do your looping in here rather than on the wave itself. Another way to do it is to type in the word loop, and you can see that we can set up looping here as well. But for the time being, it's easy enough to just set it up on that. So now that I've got that set up, I'm going to go attenuation settings, pinball attenuation, and save. After closing this asset, I'm now going to open up blueprints again, and I'm going to go to the ball blueprint. So from here, I'm going to add a component. So by adding a component that's an audio component, I'm adding a sound that will be constantly set to wherever the ball is. And this is just going to be called ball rolling sound. And I'm going to set the sound to be the cue that I just created, which will be ball rolling cue. Now, the quickest way for me to do the functionality that I spoke of is to in tick add a sequence so that sequence 0 goes ahead and fires off the impulse that we would normally use, but sequence 1, so the next value down, is now going to trigger something else. It's going to go down here and modify the rolling sound according to the current world variable. So I'm going to get the ball rolling sound, and I'm going to drop it in by holding Control and left click. From here, I'm going to type in the word volume, and you can see that we have an option called Set Volume Multiplier. So the first thing that I'm going to be doing when I make this is I'm going to modify the volume of the sound. The next thing I'm going to do is I'm going to set the pitch, and you'll see that we have set pitch multiplier. Now both of these are just after a float, and we've got to think about how we actually want to get that float. What is that value? So effectively we want the volume to go up to 1 when it's at a reasonably quick speed, and we want it to scale back to 0 when it's beneath that speed. So the simplest way for us to do that is actually to get the velocity of the ball. And now this velocity of the ball that we get returns a vector. So it's giving me the velocity in x, y, and z axes. But in this case, I actually just need the general velocity of the ball. I don't care about any of the other details. Like I don't care which direction it's currently really moving in. I just care about the overall velocity. And to do that, we need to get the length, vector length. So this returns a single float value that's going to be the speed of the ball. Now the next thing that I'm going to do is, when this is going at a reasonably quick speed, I want to have this set to 1. So the quickest way for me to do that is to say, let's pretend we want a speed of 1,000 to equal a volume multiplier of 1. So to do that, all I need to do is get the length and divide it by a number. That number is 1,000. At which point, when the speed is equal to 0, this number is going to be equal to 0, because it'll be 0 divided by 1,000. When this number is equal to 1,000, it will be equal to 1, because 1,000 divided by 1,000 is equal to 1. The final thing that I'm going to do is I'm going to clamp. So a clamp, when you run a number through it, what it essentially does is it makes sure that if a number is below 0, or below the minimum, it will equal this number. When it's above the maximum, it will equal this number. And by plugging this into here, it means that if the number were to somehow ever be below 0, it would be equal to 0. And if the number were ever above 1, it would just be equal to 1. So even if this is moving at 2,000 units per second, it would now be equal to a value of 1. So we've got our volume set up, and I'm just going to do the same thing for the pitch, but this time I'm going to set the min to be 0.97, and I'm going to set the max to be 1.2. Plug that in, and connect that to pitch. So with that plugged in, I'm going to compile and save. And when I launch the game, so I can hear it, but it might be a little tricky to hear over the music. So I'm just going to turn the music off for just one moment so we can verify that it's working. So I'm just going to disconnect my music over there for just one moment. Yep, it's definitely working. So as the ball moves, wonderful. So now we have a ball that's dynamically modifying its pitch and volume accordingly. I'm going to connect this again so that we've got something there. I might even consider turning these down just a little bit more. I'm going to compile and save. At which point, this is now done for the ball. So that's all it took to get some dynamic modifications to a file. Now, if we wanted to do this with a sound that we had created, we could do it in a number of different ways. But the most important thing to note, if you were to do it, is when you create a sound from one way or another, here we go. When you're creating the sound, it spawns a reference to the audio component. So if we wanted to modify the ball loose option for some reason, we would just promote that to a variable, and then we would modify that variable at runtime as the game was running. So we could do it with dynamically created sounds, but for the time being, that's all we really need to have. It's just a ball rolling sound that's always there, because there's never a situation where we want it disabled. So that's it for dynamic audio components. So now that I've gone through and added sounds to my game, I have some basic bumper sounds, some slingshot sounds, there are some hits that my flippers will make now, as well as some success sounds when these tiles are all dropped. I'm going to add one of the last things, which is a spinner. After the spinner, we'll be adding a forced movement volume, and then it'll be just onto aesthetics, so we can clean everything up. So for the spinner, what I'm going to need to do is import a couple of extra assets. Now these assets are going to be sm_l bracket. Just going to import that. I'm also going to grab sm_l underscore spinner. Let me just, oh, there it is there, spinner tile. So this is the tile that's actually going to be spinning. And finally, the last one that I'm going to need, SM bracket top. So this one just here. Going to drag that in. We now have the 3 meshes that we're going to need to make our spinner. So import that. So to do this, what I'm going to do is create a new blueprint. And it's going to be an actor. And I'm just going to call this BP underscore spinner. Now I'm going to need a couple of things in this. So first off, what I'm going to need is the bracket tile for the left and right brackets to be set up. So I'm just going to add a static mesh component. And this first one is going to be the left bracket, which you can see is here. And I'm going to move this 100 units to the left, so negative 100 on the x-axis. At which point I'm going to duplicate this. And I'm now going to put this one to be 100, and I'm going to rotate it around so that we end up 180 degrees. It'll be sitting just like that. Now, with the left and right brackets in place, the next thing for us to do is going to be to add the top. So I'm going to quickly just name these left bracket, right bracket. And now I'm going to add the top, which is again going to be a static mesh component. And this is going to use the top bracket that we have before. And you'll notice that when I add this, it automatically is set up to have this kind of effect. So there's a couple of ways that I can handle setting this up correctly, but the easiest of those is going to be if I move it to here, and then I just scale it by 2 along the x-axis. Now, if I just enter 2, it's going to scale on every axis at once. So be sure to disconnect that and then enter 2 on just the X. And you should end up with something that looks like this. So that's going to be our basic bracket. And if we wanted to, we could set this up in a couple of different ways. We could, for instance, make these brackets taller. And if these were taller, we could easily resize it such that the spinner would be based on the ground. It depends really how you want to use this, so I'm just letting you know that it's available. So if I push those 2 up, for instance, I could then easily bring this up, at which point you have this kind of shape. I might actually keep it like that just so it's a bit easier for you to see what's going on. So with this in mind, the next thing that I'm going to do is I'm going to add another static mesh, and this is going to be, I can do a search for cylinder, and I'm going to use one of the basic engine shapes for the cylinder. So if I drag this up, this will be kind of the pivot location for the actual spinner as it spins around. So this should be reasonably straightforward for this one. One thing I will do on this though is I'm going to be a little cheeky and turn off collision on it entirely. So that's shut down. Now for us to get a good shape on this, I'm going to get to the scale tool by pressing spacebar, and I'm just going to shrink this down so that it looks about right. That's good. And then I'm just going to scale it outwards so that it just pops through the ends. Whoops. There we go. So it pops through the ends, and we've got something like that. Now before I go any further, I'm going to quickly set up the assets themselves so that the metal bar is actually a metal bar. For these assets, I'm going to set them up within the assets, so within the static meshes. So I'm just going to double click on this, and I'm going to set each material to be just reasonably basic. So I'm going to set this to be simple yellow plastic with the metal. Save. And then I'm going to do the same thing for the top piece that we have, so the bracket top, which is also going to be, actually I might make this the white plastic, just so we have something that looks a bit different on it. There you go. Simple as that. Now that I've done this, I can see that there's a tiny bit of clipping. So the easiest way for me to fix this is to just add like 2 centimeters to the top so that it's just slightly above. That worked. 102 on the z-axis. We've now got this, and I'm going to name these before I go any further. So top bracket, and static mesh is going to be, the last one is going to be called a cylinder. Okay, so I'm going to add another component now, and this is going to be the actual spinner. So I'm going to add a static mesh component. I'm going to call it spinner, and I'm going to set the mesh to be the spinner tile mesh. So you can see it's just here. It's a good idea to now move it up, get it to a location that's going to work for what we want to do, and that seems about right, because ideally we want this to kind of hit here, and if the ball's going one way, it'll flip up, and if the ball's going the other way, it won't let it through. So we've added this to here. We've got ourselves a reasonably straightforward tile piece. What I'm going to do is I'm now going to add a very basic physics constraint that is essentially going to act as the bar that will force it to spin or not. So to do that, what I'm going to need to do is go add component and physics. And I'm going to add a physics constraint. Now, for this physics constraint, you'll notice that we have a couple of options here. Essentially what we'll be doing is we'll be telling the physics constraint to stick to this and let it twist around it in only one direction, and as far as everything else is concerned, don't let it move. So I'm going to bring the physics constraint up to this, just so it's connected to where this bar is. And at the moment you can see these circles dictate what would happen with this if it were to be connected. So let's actually connect that. I'm going to go to my component name, and I'm just going to name this component spinner in this. And you'll notice that upon hitting enter, it's selected the spinner component. Next up, I'm going to scroll down, and you can see that the angular limits are all set to free, free, free. So what that means is that this is allowed to swing on that axis, and our axis. But I don't want that. Instead, I want to lock it, and I want to set this one to limited. So by setting this to limited, I know that it can only be spun in one way. Now, the next thing that I'm going to be doing is I'm going to get this, and I'm going to tell it that the twist limits are going to be set for us. So see this section just here? That actually represents how this will spin. And if you think about how we want this to spin, we actually want this to be 90 degrees instead of 45, because it's 90 and 90, so it kind of does it in both directions. And then I'm going to offset this until it's around the other side. So I'm just going to go to here, and I'm going to type in -90. Now, the final part that I'm going to do is actually I'm going to quickly add 90 to my X rotation up here just to finish it off so that the axes kind of align. So I've added -90 to my X rotation, set that to 90 and that to -90. And we now have this. And if I were to then go down and I was to set up one last setting, which is under twist limits. So if I look at this, I can see that under angular limits, there's a couple of extra options. I'm going to disable soft constraint. I'm going to hit compile and save. Now, first off, whenever you do a physics simulation, always hit simulate first, because half the time it just falls down, which means you've done something wrong. But this looks like we're all correct. So the last things to do to get this working before we continue is make sure that the spinner has been set to simulate physics. And one final thing that I really like to do is to add an arrow component, because the truth is that we don't know which way this is going to be when it's in the scene. So I'm going to drag this up, and I'm just going to make the arrow point in the direction that I know this is going to spin in. Compile, save, and now if I were to hit play and fire it, you can see that it goes through there. And if I look at how this is set up, I can see that the arrow is pointing that direction. If I were to turn this around so that the arrow is pointing against the ball, now, the reason that didn't work the first time, but did work the second time, is due to an issue that we get from CCD. So for us to fix this, what we essentially need to do is tell the game that it needs to actually look at the collision of the ball more frequently than we have been. Because what it was doing is, in between ticks, it somehow jumped between this side and this side. This is a common problem in video games, and I'll show you how to fix that. I'm going to go ahead and I'm going to change a couple of settings on the ball, just to make sure that these type of issues never really happen again. So in this case, the ball's going to need the following changes adjusted to it. We're going to need to make sure that when I go through here, we've set ball mesh. I'm going to scroll down, and the first thing I'm going to do is I'm going to enable CCD, which enables continuous collision detection. The next thing that I'm going to do is I'm going to increase the position solver iteration count, which is in the physics section here. So if I go to this, I can now actually tell it to more frequently check the position of the ball to make sure that we actually stay reasonably accurate. So I've set this to 12 and 2, and then I'm going to hit compile and save. And this shouldn't now happen again. you'll see that now if I do a full charge straight into it, it's getting blocked every time. So we know that problem's now been fixed. So the last thing I'm going to do is put this into a place where I think it'll look good. In this situation, we want the ball to be able to go through here, but not necessarily back, for instance. I could put this over here and I could set it up that way. There are plenty of different locations that you could put this, but I personally really like it being over here as kind of an entryway to the game itself. Again, I'm going to use this arrow to make sure it's positioned the correct way. So, flip it around, and I'm just going to pop this right here. Now, since it's a little big, I'm going to scale it up. That should all work totally fine. However, we are going to get an issue that it's possible for us to not really get enough momentum to get through that sometimes, and I'll show you how to fix that next. But here's a quick demonstration of what I'm talking about. You can see that it now pops out, and the ball's never now going to get back into that area. So we'll be moving into forced direction volumes next. However, one last little detail to change here is I'm going to set this to not be gray. So I'm going to open up the mesh that's associated with the spinner, which is just under Assets, Spinner Tile, and I'm just going to set this to be white. Save. So that's our very basic spinner, and if you wanted to go further, you could potentially get this to award points as well and have a couple of them around the map and set up some more complicated behaviors. It's up to you. But onto forced direction volumes, coming up next. So the last prop that we need to add to our world is actually an invisible one, and this is going to be called a force movement zone. Now, essentially what I'm going to do is create a blueprint that whenever there's a ball inside of it, it forces it to only move in one direction. But it does in a kind of subtle way, is the intention here. So I'm going to right click, create a blueprint class, and that's going to be an actor, because we're placing it in the world. And this is going to be called BP_force movements zone. So I'm going to double click on the zone, and I'm going to add a component to it. And the component that I'm going to add initially is going to be box collision. So box collision. And this is going to represent the zone with a forced movement direction in it. For the time being, 32 by 32 by 32 is totally fine. However, when I go down to collision, I want to actually set this to custom. I want to basically ignore everything except for one thing, which is physics bodies. So we've told it that it's going to ignore physics bodies, and that should be it for our initial setup here. Now the other thing that I'm going to do is I'm going to add an arrow component, and this arrow component is going to be what we use to make sure that when we're putting it in the world, we know which direction it's facing. So I'm going to add an arrow component, which is just going to look like that. Now, for this, what we need to do is compile, save. I'm actually going to use tick here. Now, there are plenty of ways that you could avoid using tick in this instance. You could set it up so that it only does this when an object goes in, it turns it on, and when an object leaves, it turns it off. But because this is a quick setup, I'm going to set it up through tick. Just be aware that there are slightly more efficient ways that we could ultimately be running this function. And what I'm going to do is off of tick, I'm going to run a for each loop. Oops. For each loop. And that's going to cycle through an array. Which array? Get overlapping actors. So get overlapping actors gets all of the certain type of actor that is currently overlapping this actor. So at the moment I'm going to go through and I'm going to look for every single ball that is overlapping this actor. So what we need to do here is we need to get the actor. I'm going to cast it to a ball. Now I know this is going to be a ball. I'm going to convert it to a pure cast because I know it's going to be, since it's the only thing that can come out of that. At which point I'm going to set the physics linear velocity. Okay? So what I'm essentially doing here is I'm setting the velocity of the ball. Now, when I set this, I need to have a velocity to set it to. So, what's that velocity? Here's where a bit of math has to come into things. Essentially what I'm going to do is I'm going to, first off, get the current velocity of the ball. So we're going to have the current velocity of the ball, at which point I'm going to, this velocity is in world space. So if it's moving along X, Y, or Z according to the world, it's X, Y, and Z like in those world coordinates. But if I was to rotate this object, they would no longer match up with one another. So there's an interesting thing we can do here called an inverse transform, which essentially lets us get something and convert it from one space into another space. So what I mean by that is this. If I was to currently get my force movement zone, forward for this object is that arrow. So the x-axis goes along this way. And so it does with the world. But if I was to rotate this, I now have a local x-axis that's going that way, while a world x-axis is going this way. So what I can do is I can get the velocity in world space. I can run an inverse transform on it. So inverse transform the direction. And now it's going to ask me, when I add this, it's going to say, well, if you're adding an inverse transform, which object do you want it to now match? So this is converting from world space into something else. And the easiest thing for me to do there is to get the arrow, because we know that that's the direction that we always want to face, get the world transform of the arrow and convert it into the arrow's space rather than in world space. From here, what we've essentially done is we're now getting a speed value relative to the force volume that we've just created, which lets us do some pretty cool stuff. In this case, what it lets me do is run a function to basically interpolate the velocity from its current velocity into the desired velocity. And the desired velocity is actually rather simple. The desired velocity is a maximum x value that we're going to give it, or its current x value as long as it's greater than 0. So we're going to have like a minimum and a maximum clamped on the x, while the y and z we don't really care about. I'll show you what I mean by that. So if this is the direction, if I was to break this direction, we've now got an x, y, and z value out of this, which are all relative to myself. What I'm going to do here is I'm going to tell it that ultimately the speed that we want to have is going to be, if we're moving below 800 units along the x-axis, I want you to move towards 800. Otherwise, I want to use a max value of a very high number. I'm just going to set this to 19,000. I could have used a min here, but I'm just going to set it up this way for simplicity since you're familiar with clamps already. Now, you're probably sitting there going, well, if I was to just set this as my x, y, and z axes, wouldn't that create a problem? And you'd be right, because that would instantaneously set my speed to be this speed. However, if I was to use what's called a v-interp2, what this does is my current speed is this, my target speed is this, and the maximum amount of change I'm allowed to make per second is this. So I can actually set this up as the target speed. So I'm going to split the struct and tell it that the x speed is this one that we just gave it. Y and z are both 0. The current speed is going to be this, because we know we've already gotten this speed. And then finally, just before plugging it in, I actually don't want to connect that. What I want to do instead is now transform it back into world space. So I'm going to, once again, get the arrow's world transform. And if I drag off of this, instead of doing an inverse transform, I'm going to do a transform direction, which is essentially going to go, hey, this is the current space that I'm in, remove that, and it'll put you into world coordinates. Now, this is a very cheeky way to do what we're doing here, but it will work, and I'll demonstrate how this functions. The most obvious thing that could make this go wrong is if the ball wasn't set to be a physics actor, but I've just gone through and just double checked, because out of paranoia, the ball's collision is definitely set to be a physics body. So we're all fine on that front. So I'm going to drag a force speed volume into the map. The quickest way for me to test this is to actually put it in here so that I can see that it's working. So if I drop this in here and I was to point this way, we can see that this is now encompassing this entire area. Before I hit play though, I just remembered I've made another mistake. I'm going to go back to my force speed volume. I got a little eager when I added this. I forgot to set delta time or interp speed. That was a good trick. So I'm going to say the interp speed, just going to set it to 100, and delta, I'm just going to say get the world delta. So remember, delta is the time between ticks for this object. Compile, save, and this should now function. Good thing I caught that before hitting play. Now if I hit play, you can see the object is now bouncing into that zone and getting some speed as it shoots back. Now the amount of relaxation that we want to put on that is totally controllable. If I set this interp speed to be 20 instead, and hit play, it's a little bit less. Interp speed, and I set it all the way just down to 1. So that wasn't enough. So a good idea here is to actually promote this to a variable that can be set on your own asset. So I'm going to call this the adoption speed, for lack of a better word. And the default value of adoption speed is just going to be set, let's try 15 or 20. 15 sounds good. Compile, save, play, play. I saw I got that initial burst as it dropped into it, and that was about what I wanted. Now a good area of use for this is I know I always want a ball that's coming through here to go out that direction. So if I was to get this, pop it up to here, rotate it to there, and now I'm going to shrink it back down a bit. Any ball coming up into this area is now going to go through this area and pop through that. I might thin this out just a little bit as well so that we don't force the balls into the edges of that, but this should work. So that went straight through, and we should be all good. So with that, we have essentially the last prop. It's time for us to now start looking at the last game function, which is the tilt function, and from there we can then move on to aesthetics, and this project will be complete. So let's move on to the tilt function. So we're almost there. We're moving through, and we only have one last game feature to add before we can move on to aesthetics, which is putting in tilts. Now for anyone that's unaware of how pinball works, you're allowed to shake the table a couple of times before it basically stops you from doing so, and the game's over and the flippers no longer work. So what we're going to do here is we're going to add in a tilt feature, which is going to be reasonably straightforward. And the first part, of course, is going to be going into our project settings, and I'm going to go to my input, action mapping, and I'm going to add left and right tilt. So we've got left tilt, right tilt, and I'm just going to bind these to my left and right arrows. So now we've put in left tilt and right tilt. I'm now going to go back to here, and I'm going to open up my player controller. Initially, let's set up the functionality for doing a tilt, and then let's go back and work out how we want it to affect the game. So initially, we just want to do the tilt left and tilt right. So I'm going to add the events. Now, to begin with, all I'm going to do is rather simple. I'm going to, when you press tilt, I'm going to get all actors of class, and I'm just going to get any balls that are currently in the map. So I've got the ball, at which point I'm going to check if this array is greater than 0. So I'm going to get the length of it, and I'm just going to make sure that there is at least one ball on the map. And if there's more than one, all I'm going to do here is, and again this is just kind of allowing for multi-balls in the future, I'm just going to say for each of the balls that are in there, let's add an impulse to it, to the ball. So we're going to project the ball in one direction or another. And just purely out of just an initial test value, I'm going to set this number to be -500. Now, the last thing that we will do is actually add a camera shake, but for the time being, I'm kind of okay with this. So if we wanted to as well, I could get all of this and I could collapse it into a tilt direction. And if I wanted to, I could collapse this into a singular function that left tilt and right tilt call. To do that, all I'd have to do is select all of them, right click, and I would now hit collapse to function, which is now going to be called tilt. So we've now got a tilt function, but there's one other thing I'd like to do here, which is if this is a function, we probably want to change the impulse such that it works depending on whether it's left or right. Now, I'm kind of going to just hijack one of the enums we already have here. So, because if you remember before, we had an enum that we created which was used for the flippers. Now, the enum that we used for the flippers, if I open them up, was used for determining whether it was a left flipper or a right flipper. So we had flip type as an enum. So what I'm actually going to do is I might actually just hijack that enum since it is left or right, and since I know we're going to be pushing it left or right, I'm just going to make that a little bit more straightforward. So I'm going to go add a new variable to this function that we created, which is going to be called flip type, and it's just going to be called tilt direction. And the reason that I'm doing this is that this impulse we want to select depending on the direction that we're going in. So if it's left, we want to go -500, and if it's right, we want to go 500 on the X. So rather simple. The other thing that I'm going to do is I'm going to check velocity change here, so it doesn't care about the weight of the ball, it just kind of pushes it regardless. And of course I'm going to add a reroute node here to just clean this up a bit. Compile, save, and if I look at my event graph, I'm now able to duplicate this. You can see that the variable is exposed, so I'm going to go left is now right. So we now have left and right tilt, compile, save. Now, I'm going to play, and if I hit left and right now, you can see that when I hit left, the ball's going up in that direction. So that works reasonably well. It's not great, but it'll, part of the reason it's kind of weird at the moment is, so if I just mash the button right now, it's going to fly up in that direction because we're adding an impulse. So we don't want to be able to do that. We want to have a minimum time between tilts, and we also really want to kind of have a maximum number of tilts that you can do. So what I'm going to do is I'm going to expand this function, which at the moment is just assuming that you can tilt. So I'm going to go to tilt, and before I even do any of these get actors of class type of stuff, I think it's probably a good idea for me to check with the game type to see how many tilts have been done and whether I'm still allowed to tilt. So I'm going to open up my game mode. I'm going to add some extra work into there. So we now have a new variable, which is going to be called tilt count. And it's going to be an integer because we're just counting in whole numbers. And the default value for it is going to be 3 because we're going to allow ourselves to do 3 tilts. And one thing I'm going to do before I forget is when we reset the game, I'm going to make sure that one of the variables that we reset is going to be the number of tilts that we can do, which is reset game. This function just over here. So I'm going to make sure that when we reset everything, I'm going to compile, I'm going to make sure that I set the tilt count back to being a value of 3. So I'll plug this into here, and you'll notice that when I've done this, this hasn't actually updated. This is one of those things that if you duplicate the node, it'll correctly reaccess it. And I believe if I was to relaunch Unreal, it would have been fine, but for some strange reason, it doesn't always load the values straight out. So I've just duplicated that, and tilt count is now back, so that when it resets it to default. So compile, save. All I'm going to do now is just have since we're storing this in here, I'm going to go into my player controller, and I'm going to get the game mode. First off, I'm going to cast it to a pinball game, and this should always return true, so I'm just going to convert it to a pure cast. But all I'm going to do here is I'm going to check the tilt count, and if it's greater than 0, so if the tilt count is greater than 0, run through the function. There we go. If it's not greater than 0, then I don't really care too much. So we don't want to actually run it. So we're going through there. Now, one thing that I can do is that if that's false, if I wanted to, I could theoretically put in something in the game mode to disable the flippers as well, which is what a lot of pinball machines do when you go over the most amount of tilts. So all of a sudden the flippers would freeze up until the game has begun again. It's up to us whether we want to do that. To do so would require just adding a boolean to the game mode that we check against before we call flip in the flippers. It's up to us, but for the time being I'm going to just basically check the number of tilts that we've got, and if it's still above the threshold, we'll allow it. Now, after I've gone through all of this and I've completed this, the last thing that I'm going to do is I'm going to get this game mode again, decrement, minus. So we're just removing a tilt. There we go. Compile, save. So now that that's set up, we should be only able to do 3 tilts. And I'll check that now. 1, 2, 3. And now my tilt's no longer working. Cool, fantastic. So we now have a functional tilt, although it's not entirely how I want it to be, which is to say it's currently missing a camera shake. So at the moment when I tilt the screen, I really want to get the whole world kind of tilting with me to make it look like everything looks like it's been shoved in that direction. So what I'm going to do here is rather straightforward. Once I call this function to add the impulse, the other thing that I'm going to do here is call a function called client play camera shake. Now a client play camera shake looks for a shake class, which is what we can set up as a basic set of variables for what a camera shake is. So I'm going to have to go back to here, and I'm going to create myself a new camera shake. So I'm going to right click, I'm going to create a new blueprint, and if I tap on the word shake, you'll see that camera shake is available under all classes. So I'm just going to select that, and I'm going to call this tilt shake. Now when it comes to the variables for the tilt shake, the first time I double click on it, it's going to give me this, which is the standard blueprint layout. And it's got all of the graphs and everything else. A nice thing you can do is if you were to close that and then double click on it again, it would become just the default properties, which is really all we want. So it's a little bit cleaner to look at it this way. So I'm going to open this up and I'm just going to quickly set up some settings. First off, we want the oscillation to last for 0.25 seconds. Next up, we want to set up the y-axis oscillation, which is sideways for us, and I'm going to set that to 500. So that's 500 units in that direction, and a frequency of 1 means that we go there and back, so it's a full sine wave of there and back. So now that we've got that, I'm also going to set the offset as being 0 rather than random, because we want this to be the same kind of tilt every time. I'm now going to compile and save, and that should be all that we actually need to get this initial tilt working. So in my player controller, I'm going to set this to be tilt shake. And the other thing that I'm going to do is, see we have play space? When I go to the play space, I can actually set it to camera local, which means we move in the y-axis, world, which means we move the camera along the world axis, so 500 along the world y rather than the camera y. But then there's also user defined. Now user defined is a very useful one for us to use in this situation, because if I wanted to, I could actually go ahead and set it up so that we can use the same shake to tilt both left and right. Because tilting to the left is the same as tilting to the right, but just rotated 180 degrees for the play space. So to do that, what I can actually do is I can actually set this up to have a select on it, just like before. So I'm going to use this node again that we had. And all I'm going to say is if it's the left, then let's go ahead and get the camera, so get the player camera manager. There's a nice little function called get camera rotation. So if it's the left, we want to use that. And if it's the right, we want to rotate this camera by 180 degrees, which I can do so by combining rotators. So if you imagine the first one is just getting the rotation and the second one is rotating it 180 degrees on the yaw, which is the z-axis. We've now got ourselves a function that should move the camera left and right accordingly. So I'm going to save, hit play, and now when I fire the ball and I hit shake, you can see that we've now actually got the tilt happening until I can no longer tilt anymore. Everything else is good. So from that, we've now got the last of the actual gameplay features we wanted. I would strongly recommend trying out some stuff, like putting some blocking in there, so that when you hit the max tilt, we go ahead and we stop it from tilting anymore. Easiest way to do that is to use this this false node to set up a boolean that connects to a branch, but I want that to be something that participants work out on their own. So moving on to aesthetics. So it's time to make everything start looking a little bit nicer. And the first thing that I'm going to do is I'm going to quickly go through and fix up our lighting setup and our fog and everything like that. That's kind of legacy from when we first started the project. So I'm going to go to my world outliner and I'm going to just delete my atmospheric fog. Now that I've done that, the next thing I'm going to do is click in the background and just delete these clouds. For my directional light, I'm going to click on this, and I'm going to start configuring this in a way that it's actually going to be not casting as strong of a shadow, but rather something that's a little bit more kind of, not quite straight down, but only a little bit of a shadow getting cast onto the playfield. Now, it's a good idea at times like this. I'm going to hit play, and then I'm going to hit stop, and then after I've clicked on the screen, I'm going to hit Control 1. And the reason for that is that actually bookmarks where the camera currently is. So if I was over here checking this out, looking at that, and then I hit 1, I can always just see what it's going to look like from a play perspective. So now that I've added that in, let's have a look at some other things that I need to do. Well, first off, I'd really like to be able to see this area a little bit better. So I'm going to start tinkering with this camera and putting it into a position that I think is going to be just a little bit nicer for play. So I'm going to move it up top, and I'm going to tilt it down just a little bit. And the other thing I'm going to do here is when I grab here and I pull it back, initially I'm going to pull it back a little bit too far. But you can see here that we have field of view, and if I change this, doing this and pulling it down this way actually kind of changes the lens a little bit. And more importantly, by dropping this to about 80 degrees or so, it actually makes this entire world closer to being an orthographic camera. So it makes it closer to being like a more flattened out perspective. When I hit play now, you can see that the camera ending up in this position has made this channel far more visible, and I can still see the rest of the world reasonably well. So you can see my settings over here if you want to use them, but I think that's probably a good move. It's also a good idea here to bookmark the new camera position, so I'm going to hit Control 1 again. And don't be afraid of like changing this around. You can leave different like Control 4, 5, 6, 7, 8, 9, 10 for different perspectives. For instance, if I was going to have the menu in the game over here, I could hit Control 2, and then I would have 1 and 2. And I could switch between those positions as I'm mapping and modifying and changing things. So with that in mind, we've got a rather simple setup for a camera. Let's actually go through and start setting up everything else. Now the first thing I'm going to do is add a frame around the table, just something to make it look a little bit more like an actual pinball table. I'm going to go to my pinball assets, and I'm going to import the asset down at the very bottom called table frame. I'm just going to drag that straight in, and I'm just going to click import. For this asset actually, I'm also going to disable collision because it's purely there for aesthetic reasons. And you'll notice that we now have a simple frame. So I'm going to drop this into the world, zero out its x-axis. It's a good idea to change your snap grid at this point. I'm just going to zero out all of the axes actually. So now that we've got that in, I'm now just going to scale it across and then start positioning it just so it's a little bit nicer with where it sits. It's a good idea to go into unlit mode if you're trying to get it scaled up correctly. Alternatively, I can click here, I can go to my top-down camera, and I can see whether or not it's fitting the frame. At the moment, I can see pretty clearly that it's not, so I'm going to tinker with that first and go 1.4. Oops, these were scaled in the process. So 1.4 seems like it'll work. We kind of want this to be sitting... We want this to be sitting here, but this to be here. So 1.4 is a little big. 1.45. That seems pretty good. And now for the y-axis, I'm going to change that to be just a little bit lower. I'm going to try 0.9 initially. 0.925 seems pretty good for my setup. This is going to change depending on who's doing it. So I'm not too concerned. And when I go back to it here, I go back into lit mode, hitting play, that gives me this. And I can see it's probably a good idea for me to change my directional light around as well. And another option that I have here is getting the camera. Now, if I want to pull the camera directly back, a nice technique is to click here and switch it into local space, at which point I can actually just pull it directly back, which I just did then. And that does look a little bit nicer. So I'm now going to fix up my lighting. I'm going to turn this back into world space. I'm just going to give it a little less. There you go, that looks quite nice. Another potentially good idea here is to add in a light source for a general skylight. Now initially the light source isn't actually going to capture much and it's not going to look right. And that's because it's trying to capture the scene around you to create ambient light. Because we don't actually have one, my suggestion is to switch it from being captured scene over to being a cube map that's been just pre-captured. And once I do that, I'm just going to select a cube map that I think will work. My gut says that sunset could work. Alternatively, epic quad panorama. Gives you just a little bit of ambient lighting kind of bouncing around. I'm also going to turn it down just a little bit from being 1, so that's the difference between them. I'm going to push it down to about 0.25, just so it's bright, 0.3, so it's brightening things up, but not by too much. So we now get this. So that's starting to work. And at this point, I think it's a good idea for me to also start considering how I'm handling the brightness of the scene, because this is not actually going to really require any post-processing beyond like some bloom. I'm going to go ahead and drop in a post-process volume, and I'm just going to move it across to the side so it's easy to find. I'm going to tell it to be unbound, which means you don't have to be inside of the volume for it to take effect. And then I'm going to go down, and the first thing I'm just going to disable straight up is going to be the eye adaptation, which is auto exposure. So I'm going to go to that, and I'm just going to tell it the low percent and high percent. You can see the values that are set up here. Now, the way that you can kind of turn off exposure by default is if I set the min and the max brightness to be the same thing, it now won't adjust. If those are equal to one another, it completely turns off the feature. So that's actually good for us because it means I can use that to balance everything else out. In this case, I can see that, yes, I did put in the skylight before, but when I turned it down, I was turning it down as a way of compensating for the adaptation that was going on. So I'm going to turn that back up to 1, and we've got this. A little bit nicer. Cool. Just going to make sure that this is all good. You can see that I'm not particularly good at pinball. There we go. So this all works, everything's fine. I can see that my multipliers are still good. So we've got a score that's racking up, and I've got an environment that's starting to look a little bit nicer. But let's actually get this going another step forward. So the next thing I want to do is have an environment along here that kind of looks a bit more like a glossy wood. And a good way for me to do that is to go back to my assets, and I'm going to import the texture that we use called fibers, which is just t_fibers. So I'm going to drag that in. Now the fibers texture looks like this. Oops, just loading up. But we're going to use this to make ourselves a basic wood material that we can use as a way of having like a nice backboard. So it's a little ugly now, but it'll be good in just a moment. I'm going to right click and create a new material that's just going to be called m_tabletop. Capitalize the T. And within this, I'm now going to start setting things up. So the first thing that we need is a color. So this is going to be, I'm going to hit V, and I'm going to make a parameter called table color. And this is going to be, I think a deep red would be nice. I'm going to get rid of the green values from this to kind of make that kind of deep red. So 0.2600, that's what we have. Now if I was to just plug this into my base color, hit apply, save, we would have ourselves a very basic table color that we could use. And you know, that's actually kind of a nice color to have. So I can look at that and see that it works in kind of an interesting way with the yellows. But let's go a little bit further. So let's go ahead and actually add those fibers in to make it look a little bit more interesting. I'm going to add a texture. I'm going to type in fibers. Now that we've got the color and the first fiber texture in, I'm going to basically add in a thing that says I want 10% of the fiber to be added to the table color. And a nice way to do that is with a lerp. So if I connect this with this, we would end up with a blend between the two. So you'll see it on the left hand side as I go. Now that's initially going to be white. But what I actually want to do here is I want to set the value of the fibers being kind of blended into it as if they were also colorful. So instead of lerping this against this, I'm going to multiply the color against the fibers first off and connect those two. So you can now see that it's a bit more like that. And now the next thing I'm going to do is I'm going to get the alpha. And if this was equal to 0, it would be all that. If this value was equal to 1, it would be all that. Instead, I'm going to set this to be about an 0.1, so there's just a little bit of the fibers coming through. And I'm going to convert this to a parameter, just so we can change it later if need be. I'm going to call this fiber blend. Now the other thing that I want to do is I want to make this look not just up and down the grain, because if I hit apply and save and I look at this, what we have right now is that, which is just running up and down, which looks okay, but it's not the final result that I really want. So I'm going to get this, I'm going to duplicate it, and this time what I'm going to do is I want to have this going sideways, not just up and down. Now the common thought here is to rotate, add a rotator and move it around that way. But there's a nice function that if I hold down U and left click, this gives me my X and my Y coordinates that are going to be going onto this image. And I can use a function called swizzle, which lets me swap the X axis with the Y axis. And if you think about what that does, it actually makes the image go sideways instead. So I'm going to multiply these two against one another. And I'm just going to increase this blend initially so you can see it a bit better. You can now see that we end up with this kind of pattern going on instead. So I'm going to set this up to be 0.25, is looking a little nicer. Save. And that's a bit nicer for me. The other thing that I think I kind of want to have going is I want to control how big these are. At the moment these are very small little lines, but I wouldn't mind them just being a bit bigger. Now I could just get this and plug it into, I could just increase the coordinate size here. But it's always a good idea to parameterize stuff like this. So what I mean by that is if we multiply the texture coordinate size against a number, we can actually change the scale of that number. So if I get this number and I plug this into a multiply, when I get this, if I multiply it against the number 5, for instance, you can see it's, I'm going to make this a bit clearer by just changing this up to 1 again. If I multiply it against the number 5, it'll be here. 1 is here. 0.2 is here. So you can see that a smaller number makes it a larger texture. So I'm going to go, for the time being, 0.25 we'll try out. And I'm going to set this blend back to 0.25. Which looks a little bit nicer to me. We've now got like a nice red wood that we can use. If I wanted to as well, I could use the fiber to change how this is reacting for the roughness values, but to be honest, the base roughness actually looks quite good, I think, for the table. So we've got that going. I'm now going to go through and set the rest of this up. I am going to quickly just match the colors between everything by going to my assets. I'm going to drag in this tabletop material onto all of the floors so it's consistent. Now if I look at these, it might be hard to see, but they don't entirely align. If I control click on all of these and then I go to alignment, align surface planar, it actually puts all of them so that they're perfectly aligned with one another. I missed a surface just then, so that was a good trick. But if I click alignment, align planar, they actually now all match one another so that they all blend in correctly and there's no seam, which is a nice little technique. So I've added this initially. Next up, we're going to look at how to add some decals so that I can start just adding in some cool symbols and stuff along the board. What I'd advise for the time being is spend some time just dropping in some materials so that you can kind of set up the board in whatever way you see fit so that we've got some color in there for the actual frame. I'm just going to go through and do that myself, but for the next session, we'll meet up and start doing decals. So I've gone ahead and done a very quick pass in just making the thing look a little bit better, just getting some block colors in there and that kind of stuff sorted. Now the next thing I'm going to be showing you is going to be the actual decals. And we're doing this because at the moment we have a reasonably blocked frame. You can see that we have a reasonably blocked out frame. We have, well, I mean, just an environment that could look a lot better. So let's start kind of getting some arrows in there and some symbols, some logos, that kind of stuff. So I'm going to go ahead and I'm going to import two textures we have. I'm going to import decal pack 1 and decal pack 2 textures. Now these are textures I've made ahead of time, and I'm going to show you how they're set up. They might look a little bit ugly at first, but I'll explain what's going on. If I open up decal pack 1, we have this. But if I look at what's going on here and I turn off the channels, the red layer looks like this, the green layer like this, the blue layer like this. The other thing I can do here, if I want to try and improve them just a little bit, is I can go down and tell these to be masks, so they know that they should be set up in that way. So these are all packed into a single texture where red, green, and blue signify different images, and I've done the same thing for a second set for decal pack 2, which is just here. So what I'm going to do from here is I'm going to create a new material that's just going to be called m_basic decal. And we're going to instance this for other things, but for the time being, basic decal is literally going to be a texture. So I'm going to hold down T and left click. I'm then going to set decal pack 1 as my texture. Now we're going to need some way to select which of these colors we want to use. The easiest way for us to do that is to use a component mask param. So if I drag this in, and this comes into here, this parameter lets us choose red, green, or blue from a texture. So in this situation, I'm just going to have this selecting the red channel, and I'm going to call this decal channel, so we can change this to whatever we want. And the other thing that I'm going to do is hold down V, and I'm going to have a decal color. And this by default is going to be, let's go with something that's slightly, oh actually the blue could look nice. Let's just go for that for the minute. And how this is going to work is this is going to set the opacity of my decal, and this is going to set the color of my decal. So to set this up as a decal, what I need to do is I need to set this to be a deferred decal, just here. And you'll see that when I do, if I go base color and I plug you into the opacity channel, I now also need to set the blend mode to be a debuffer translucent color. Now at the moment what we have is a slight issue where it's not going to work because opaque needs to be changed over to translucent. So it needs to know that it actually is a translucent material. And you can see that we've got this now appearing over here. So if I were to hit apply, save, and just quickly test this asset, what I would see would be this. If I got this, and I added a deferred decal into the map, and I set the material to be equal to my basic decal, you can see now that we can paste things in. Now this is a reasonably low res image that I've used for my decals. It's just a 512 by 512. So we could up the quality here if we want to get something a bit more substantial. In this situation, the more I look at it, the more I think that it would be a good idea as well for us to use a white as a basic color instead of a blue or anything like that. So I'm just going to go out and set this to 111 so we have a white standardized texture. Good. And the other thing that I'm going to do to kind of just clean it up a little bit is at the moment you can see that there's some artifacting going on from the texture itself. And there's different ways that we could clean this up, but the easiest way for us to do it is, because we're using a hard mask for every single one of these textures, it means that we don't really need to care about any gray values. So what I can do here to kind of clean it up is I can run a power and plug that into the opacity channel here and just crank the power up to like 4. And you'll notice that it should start getting rid of some of the jaggies along the edge. Now, the alternative to me doing this is to multiply by a small number first, say 1.5, and then clamping that at the end. So essentially what we're doing here is if any values are very gray, so they're very close to being the right color, it's going to grab them and push them up so that they're all there. I'll show you what that looks like. And then when we power it, it's going to then make anything that's below white darker, and the clamp is then going to just clamp it off this way. Now this still has some issues with it, and ultimately at the end of the day, the better solution is to actually set these textures up as a higher resolution if we want to try and save memory, but this will do for the time being. So we've got our first very simple decal in, but how do we make the others? That's rather simple. I'm going to create an instance, And I'm actually going to make a couple of these, including one that's actually just a blank instance, purely for us to have something to work with here. So it's going to be called mdecal_ straight arrows. It's going to be the first one. And this is actually just going to have these options enabled, but not changed. I'm doing this so that if we ever modify the base, I still have one for the arrows. So I'm going to change this basic decal to be straight arrows instead. And you'll see no change whatsoever. So this one here, I'm going to put here. And I want to set this up to be, at the moment it's at -220. So if I were to drag this and just change it to 220, you'll see that we have this nicely set up. Somehow this isn't quite at the same point, so I'm just going to move this over a little bit, just so it's a little better balanced. Cool, so we've got that set up now. We've just got some basic arrows kind of pointing down. The next thing that I'm going to do is I'm going to duplicate this, and I'm going to make this new one called decal_ curved arrows. And if I double click on that, I can now change this channel to be a different one. If I want to see this a bit better, I can make this a box. So at the moment, this value is equal to the red channel, but if I swap this over to be the green channel, we get that instead. So save. And now again, if I want to drop in a deferred decal somewhere, while that's selected, I'm able to kind of place in some nice little arrows. It's always the last one you check. There we go. So I've now got some base little arrows there. Now be aware that these will project onto everything. So if you look here, you can see that this is actually projecting onto these surfaces as well. Sometimes you want that, sometimes you don't, but the easiest way to fix it is to just simply change the scaling along that axis. So if I hit spacebar twice, I can see that the axis that's up and down is this red one. So if I change that to 0.2, it's now only going to be painting stuff in that region. So the decal is only going to be projected in a very thin area. So again, I'm going to go here, 0.2. And I'm going to do it for these as well. Because the other thing that they will decal right now is if the ball were to go over them, they would actually spray onto the ball dynamically. So that looks alright. It might be a good idea for me to tweak things off, but this is good for the minute so you can kind of get an idea as to how it looks. I'm now going to create another one. So once again, I'm going to duplicate, and this is going to be duplicated to be equal to the edge, just kind of like a generic tech edge piece. So this is going to be equal to the blue channel. Save. And if I drag in a decal, you can see that we've now got that tech edge kind of going on up there. So this is rather simple. What I'm going to do next is I'm going to bring this across, and once again, so you can see there that it's projecting onto all of the assets here. So the spline mesh is getting it as well. Can right click here, and I'm just going to mirror it on this, mirroring on the local Z, which is timesing this one by -1. And I'm just going to make sure this is kind of nice and tucked away into the corner, just for it to balance the others. It's good enough for the minute. I'm going to set this to be 0.2, as we've been doing. So we're starting to get some general tech kind of look going on. I'm going to duplicate this one and make it the generic stripes. So this is the decal underscore, which we call stripes. Now, at the moment, this is actually missing a parameter. What I haven't done is I haven't set the texture parameter that feeds in the texture as a parameterized section. So I'm going to go back to the basic decal, and I'm going to right click on this and convert it to a parameter. And I'm just going to set the parameter name to be equal to decal map. I'm going to save that. And then if I go back to stripes, I can see the decal map is now an option, and I'm going to set it from 1 over to 2. So I'm going to save this, and I can now drag that in to have kind of like a warning area that I can use as my as the decal down below. So I'm going to get my deferred decal, drag it in, and I'm just going to quickly set this up to be along this bottom row. I don't mind condensing these lines down a bit because I think it still looks okay. So I just want to kind of put that there. Zero it off so it's in the middle. And I'm just going to set this up to have a little bit of a gap. Final setting is going to be making sure that the x-axis is zeroed out to much smaller. Much smaller. So just quickly setting that up. So we've got something to work with. Now the next thing that we're going to be going into is a slightly more advanced form of decal. So come into the next lesson and I'll show you how to do debuffer decals that actually change certain parameters beyond the color. So we've gone and added some very basic decals, but what I want to do now is something a little more interesting. We're going to actually start using decals to modify more than just the color property, and to do that we need to actually go into our project settings, into our rendering settings, and we need to enable a feature that's not on by default. What we need to enable are debuffer decals. So I'm going to go to there and I'm going to type in the word decal, and you'll see that we have debuffer decals. Now if I enable this, be aware I'm going to need to restart my editor. So I'm going to do that and then follow along from there. So we're back now, and you'll notice that it's going to seem like everything's broken, but that's okay. What's happening is, unfortunately, when you enable debuffer decals, the engine needs to actually go ahead and recompile every single shader. So it might take a minute or two for it to adjust, but I promise you that the results are going to be worth it. What we're going to be doing from here is actually setting up a decal that modifies more than just color. It modifies either metallic or roughness as well. So what I'm going to do is I'm going to use the two Unreal textures that we have here, which are number one. I'm just going to show you the two channels. So the red's this, which we've used already. Green is a kind of a fat version of the logo, and blue is the logo itself. Now the reason that I'm doing it this way is so that I can use this green section as kind of like an outline, and the blue is the inside. So we've gone through, and it's gone and rebuilt all of its shaders. What I'm going to need to do now though is I'm going to duplicate basic decal. I'm going to make this new one called advanced decal. I probably could have a better name, but this will do for what we need to have done. Now what I'm going to go to is, if I scroll down here, you can see we have decal blend mode. Now at the moment that's set to translucent, so it purely puts out just that one texture. However, if I want to, I actually have a whole bunch of different options here. In this situation, the one that I actually want to change is color and roughness. So if I go to this and I set up color and roughness, this will now actually let me set a very smooth surface for the ring of one decal map and set up the other as the interior color. So what I'm going to do here is I'm going to change decal map to be pack 2. Now that's going to be setting up the, if I go to view all, for the time being I'm just going to set the roughness as a default value of 0, and from here what we need to do is I'm going to just demo it in the world so you can see what's going on as we create it. So I've created the decal. Once again I'm going to drop it in as a decal setup, and I'm going to set my advanced material to this. Now at the moment advanced decal is running off of that, and that's okay. But what I'm going to do is I'm going to quickly show you what this would look like if, instead of running the opacity through this channel, I was to run, it's weird that hadn't updated, but instead of running the opacity through this channel, I was to just use that exclusively on roughness, just so you can see it. Apply. Okay, so we can see this a little bit better now when I set it to black, but you can see that we now have shiny, not shiny, shiny, not shiny, shiny, not shiny, which is a nice little setup. It means that we can kind of use those in different ways. What I'm going to be doing here is I'm going to set up the base color to be equal to the Unreal, whatever Unreal logo color we want to have. I'm then going to, I'm then going to set that up so that we have that on a separate mask param, just in case. So there's going to be an inner layer and an outer layer. So I'm going to rename them accordingly. I'm going to make decal map 1 and decal channel 1. Oops, that's a good trick. And what these are going to do is they're going to set up the basic opacity of the material itself. So I'm going to plug that into here. Now, because I know I want to run off of some reasonably basic channels here, I'm actually going to go ahead and preset this up to use the green channel, because I know I want that to be the main channel. Oh, sorry, not green, blue. So we've got the kind of fatter one as the general opacity. And I'm going to set the roughness for that one to be equal to a LERP